Okay, we're going to start our last topic in the course and in this unit. So we've looked at different types of integrals, we've done reverse power rule, we've done a reverse chain rule, we've looked at logs and trig and all that kind of stuff. So our last thing to do is what happens if none of those methods work and we get into a quotient or a product type situation. So the quotient rule backwards is called partial fractions, and the product rule backwards is called integration by parts. So today we're going to go through just the partial fractions, just the quotient rule one, because it's almost too much for one lesson. And then tomorrow we'll do the integration by parts. So to start with today, we've already looked at some integrals where they've looked like quotient rule, but we've used different strategies. So if we had things like x squared plus x plus 5, and we divided, say, by x, we didn't do this as a quotient rule, we just broke it apart into a series of divisions, right? Because there's only a single term on the bottom, we can divide each thing out by that x, and then we could simplify it to a power rule situation. So the last one in this case becomes a log, which is fine, but we can see that we would get three separate terms. So now the antiderivative would be 1/2 x squared, and x for the 1, and then the 5 over x would become a natural log. So, and we'd have to put plus c on there. So we've done sort of like convert the question into a power rule, or we've used logs if it didn't work as a power rule. And then we've also looked at things that were almost like a chain rule. So if I had something like, let's suppose it was x divided by, let's do x squared minus 5 squared. So this one, we looked at it as almost like a quotient chain combo, but really we only had to worry about it as a chain rule because that bottom term, if we write it, think of it as being like x squared minus 5 to the negative 2. If we raise the power, divide by the new power, but then we'd also have to divide by the derivative of the inside, which in this case is 2x. So in this case, we didn't have to worry about it as a product or quotient because those x's canceled out. So we just get negative 1/2 times our brackets. So we've looked at a few scenarios that have been quotient rule type questions, but we haven't had to do the quotient rule because we could kind of change them or use a different strategy. What we're going to look at today is where we have to do the quotient rule. So integration by partial fractions is basically going to be sort of our last resort for questions that don't work with any other method. So you can see on this example that I have on the bottom of the page, we can't divide out everything by x plus 1 because it'd be two terms on the bottom and it's not going to give us any, like the first couple wouldn't work, the last one would be a ln. It doesn't work very well. We had a question earlier on our worksheet. Maybe let me just jot that one down quickly. So we had one that was something like x cubed minus 1 over x minus 1. Even though that's a quotient rule, we did it as factoring so that we could cancel out those x minus 1. So once we factored the top, the bottom canceled, and then it just became a regular power rule. So this situation, that would work too, but 2x squared minus x plus 1 doesn't factor into x plus 1. So that's not going to help either. So our strategy that we're going to use for these is to use long division. We're going to try to use long division to rewrite it. So you might remember from Math 30, if we took a fraction or a quotient of two different polynomials, something like this, we could actually do long division to rewrite that question. So that thing being divided, once we do, let's do synthetic, if we change our coefficient out front to -1 due to the opposite of the bottom, and we make our coefficients along the top, and then remember we bring the number down, bring down the 2, multiply -1 times 2 would give us -2, add those together, multiply again would give us +3, add those together, we get 4. So remember what this does is it changes the question from, basically it factored it, we factored it into 2x minus 3, but then we also had this 4 remainder. So if there's a remainder, that means it doesn't factor, which also means we have to include that as our answer. So we keep the 2x minus 3, but we have to write it as plus 4 divided by the bottom term. So these two things are exactly the same thing. So if that's the case, we can now do the integral of that. So this integral we couldn't do, but now this integral we can. So now it just becomes a power rule for the first two terms. So raise your power, divide by 2. 3 would turn into 3x. And then our last term becomes a ln, right? 4 over x plus 1. That's an okay derivative or integral to do because it's just a regular ln question. And that would be it. That would be our final answer. So really the only extra trick we're doing with the quotient rule is do the long division or synthetic division first, and from there you can simplify the question. So most of today we'll be practicing just remembering how to do the synthetic and the long division, and then we should be in business. So our method for these complex questions will be to do long division or synthetic division to simplify it into a sum of a bunch of terms. And that's where the partial fractions comes into play. We turn one fraction into a whole bunch of separate terms, and the last one typically is our only fraction left that we do a logarithm with. With whether you decide to do synthetic or long division doesn't really matter. Generally speaking, if the bottom is an easy term, like just x plus 1, synthetic division will work. But you could, if there was a number in front, like suppose there was a 3 or something, then you're going to have to do actual long division. So let's practice this question as a long division, just so we can remember how that works. And we did it earlier in this course when we were doing oblique asymptotes. We did long division, but we didn't need to worry about the remainder. In these questions, we will have to worry about the remainder. So let's write it out as long division. And remember, we want to put the 0 in for the x term. And now with long division, we basically divide each term out. So x cubed divided by x would give us x squared. And then we want to FOIL those out. So x squared times x is x cubed. X squared times 1 is x squared. And then remember, we need to subtract all of these. So when you subtract, we will flip our signs. So then our first ones cancel, and then we would get negative 2x squared left over. And now we start all over again. So how many times does x go into negative 2x squared? It'll be negative 2x times, and then we FOIL that out. So negative 2x times x would be negative 2x squared. Negative 2x times 1 is negative 2x. And I didn't carry down my 0x, but let's bring it down now. And now, once again, we need to subtract. So if we subtract, let's flip our signs. So those first ones cancel out again, and then we get 2x left over. Let's bring down our negative 1 again, and we do it one more time. How many times does x go into 2x? It would be twice. FOIL that out. Gives you 2x plus 2. Subtract. So when we flip our signs, those ones cancel and we get a remainder of negative 3. So whether you do synthetic or long division, it really doesn't matter, whatever method you prefer, or for the tougher ones you're going to have to do long division. And then we simply rewrite our question now as x squared minus 2x plus 2, and we'd have a remainder of 3 over x plus 1. And from there we can just basically do our regular power rule for the first terms. So that'd be 1/3 x cubed minus x squared plus 2x, and then our last term turns into the logarithm. And because the bottom is just, the derivative of the bottom is just 1, we don't need to worry about the extra step with the logs. We just keep the 3 out front, and everything else turns into your logarithm. Just like when we did integrals before, we can do this with definite integrals. So if there's numbers in front, that doesn't change our strategy. We still need to do long division or synthetic division first. Once you do that, then we would just plug in our numbers and subtract our values just like we do with normal definite integrals. So for this one, let's do synthetic this time. So let's put a 1 out front, and let's go to, we have 0x and a 0, which isn't written there, but we still need to put those zeros in. So now we'll bring down the 2, multiply 1 times 2 gives us 2, add those together, multiply again, add again, and we're finished. So in this case, our question would change to our integral from 2 to 3 of 2x plus 2 with a remainder of 2 over x minus 1. So we do our antiderivative, which would be x squared plus 2x plus 2 ln x minus 1. We don't need to worry about the plus c, but we do need to plug in our 2 and 3 values. So let's start with the 3. I don't have a calculator, but I can probably do it mostly in my head. So plug in the 3, we'd get 9 plus 6 plus 2 ln 2. And then we'd plug in the 2, we'd get 4 plus 4 plus 2 ln 1. And we can clean that up a little bit. 9 plus 6 is 15 plus 2 ln 2. That's just a decimal. I'll leave it as 2 ln 2. And then we'd have 8. 2 ln 1 is 0. Ln of 1 is 0. So we just add 8. So 15 minus 8, we could write it as 7 plus 2 ln 2. Or you could type it in your calculator and get that as a decimal value. That would be acceptable as well. So that's basically it. Do your long division or synthetic division. Change the question into a different format where it becomes a power rule and a log combination instead. The only kind of question that we haven't covered, and we won't cover because this is sort of beyond the scope of this course, is what happens if the bottom was bigger than the top. So when the top is bigger, we can do long division, but if it's the other way around. So if I gave you a question that was something like 3x minus 1, but now we're going to divide it by x squared plus 4x plus 4, long division doesn't work because the bottom is bigger than the top. So the method, or the way you'd actually have to do these, is we'd have to use some sort of algebra trick to change this question. So this would turn into something like a divided by x plus 2 plus b divided by x plus 2 squared. That's kind of what this equation would look like. So then we'd have to figure out what the a and the b are, and then from there we could use just a chain rule type of situation. So there are other methods for this, and you can see these 5 formulas that I copied from the internet are just different versions. So this is like a linear divided by something that factors. This number 2 is similar to the one I just did. And then you can see we got a quadratic divided by a cubic, and there's different versions of that. And you can see different formulas, A and B's and C's and all that. So these we will not teach, it's beyond the scope of this course. So just be aware if we ran into one of these situations, it could be done, we just don't know how to do it yet. You'll learn that down the road in further calculus courses. So for this course, it'll either be a question where you could write it as a power rule. So if I gave you something like 4x divided by x squared, or we could even do like square roots, then we could change it to a power rule. And then from there it could be a log, a power rule, or anything like that. Or we would get it where we would do this previous method where we do the long division and then simplify the question that way. And that's all for today. We'll move on to the reverse product rule tomorrow.